Jossie Henning, Alexa Ford, Lucy Schmidt, or no, Simon Schmidt, excuse me, and Haley Mullins. Please come to the office.
Everyone's going around school here.
What? That is not going around school. That's what I heard. That is not going around school.
That's what? What am I missing out there?
Everyone knows you're not to dress up to school. I dressed up. I dressed up as a race car driver. Really? Whoa, that's you. What? Oh.
I filmed that whole day.
What?
Hey. That part was I would have thought I was just terrible. I just guessed based on my
Dalton Kelly, please come to the office. Dalton Kelly.
I would much rather miss PD than that.
Really?
I would much rather.
He's played long mission.
Alright, today, what we're going to talk about today, I want to review slope-intercept form, point slope form, all that good stuff, but we have to talk about parallel and perpendicular today, because they're the two topics that go with what we've been learning. Okay, so you need your notes out for right now. After a little while, I'll give you a little bit of time where you can work on this page 188. That's the stuff I had to do tomorrow, so I will give you some time today where you can actually look at that. I know it takes a little bit of time. If you have not picked up graph paper, I'll hand some of that because I know there's at least those last select few. You do have to graph them. You do have to graph a few. Okay, and those just the last ones where they give you kind of the equation.
The last one you were here.
Okay, the last one. It's like 40 through 48 evens, 50 evens, 50. They ask you to graph those. The ones in the beginning are just like point slope, or just write the equation down in the point slope form. It's like it's real quick. But those last few take a little bit of time, so that's what we'll need to make sure of. Okay, all right. So that's what we're gonna do right now. We're gonna try to do a quick review. Now remember, this Thursday we have a testing here. Okay. We'll do the review tomorrow and Wednesday, but I want to make sure that we know how parallel and perpendicular work. All right. So the section we're on section 1.5 on the stuff, and it's just parallel versus perpendicular. Okay. That's not the title of the section of the book. I think they just say like more on slope. That's all.
Dalton Kelly, please come to the office. Dalton Kelly.
All right. What I want to review is kind of get us back in the swing of things. I want to talk about those different forms of linear equations. I mean, this is like a perfect lead into what you have to do for your homework. So I mean, it's a good, nice little review. So linear equations or linear functions, whatever you want to call it. I just want to make sure that we do know little forms. So like the first one is the go-to form. That's the one that I like the most is point slope. Point slope form. If you don't remember that formula, it's y minus y1, mx minus x1. That was the form that we talked about. The x1 and y1 are just some coordinate from your picture. The m is your slope from the picture, from whatever it is. Now, I don't, when I calculate slope, don't do that thing where you look at the picture and you count with your fingers. Don't do that. Like, actually use your slope formula, the average rate of change formula. If you don't know what the average rate of change is, this one, where you actually subtract the y's and then subtract the x's. That's called an average rate of change. Okay, that's what they call it, or slope. But I recommend that you do that, so they're going to give you two coordinates. Right? That's what you have to do in a couple of different programs. So, that's your point slope form. And again, once you find the slope and you have your coordinate, just plug in, and we'll do an example here in a second. Number 2, that was slope-intercept form. Slope-intercept form. On this form, it's really great if they start with this equation and then you graph it from there. So not going from graph to formula, but formula to graph. That's where the second one comes in really well, and that's y equals mx plus b. And why this one's easy is the b number is where you hit the y-axis, so it's called y-intercept. And then the slope, you go from there. That's where you just go up and over, down and over. I always go towards the right, so it's either up or down, and then going towards the right, and then you draw your line. So that's slope-intercept form. But again, we use that one for graphing. That's like the main purpose. Third type, the standard form. We use this for story problems. At least in algebra 2 anyway, and for systems. We'll get back into systems later. That's a later chapter when we get into vectors and we start getting into the trig functions. We'll start learning how to solve systems and stuff, especially with matrices and stuff. But standard form, if you don't know, it's this: ax plus by equals c. I just require that for a, b, and c, they have to be integers, just whole numbers, no fractions, no decimals. I don't know if we did a problem with decimals yet for that. If you do have a decimal in your problem, we typically multiply by a 10, 100, 1,000, whatever digit you need to multiply by, that will get rid of all the decimal places. So how do you get rid of decimal places? For every 0 that you multiply by, so like a 10 has 1 0, it gets rid of 1 decimal place. It just moves the decimal over 1 on every single coefficient. If it's 100, it moves the decimal over 2 spots. So you just kind of look at your problem, see what the biggest decimal is, and multiply by the appropriate multiple of 10. That's standard form. And then for number 4, that is general form. It's just basically standard form. You just rearrange it a little bit. I mean, all these are basically the same form. Just do we understand what they're giving you? General form is where it looks like standard, but you have a 0 on one side. We typically use general form for when we are factoring and we're trying to solve for quadratics, like when you're learning how to find the zeros, something like the x-intercepts, where you factor it apart and you figure out which parentheses equal to 0, that kind of thing. So that was general form. Well, the goal today, obviously we have a title called parallel and perpendicular, right? The goal is to take these and figure out how to write a parallel line and a perpendicular line for some information I'm giving you, okay? And to put it into one of these correct forms. So it's really kind of a mimicking like what you did yesterday. So for instance, let me just give you a line here. So in fact, I'll let you guys kind of create it. So I want an equation in slope-intercept form, please. So y equals something. Give me some numbers. Easy numbers, small numbers. Okay, 3 over 7. Let's do that. 3 over 7. X plus or minus a number.
7 over 3.
Let's go plus 2. I don't want to go any weird decimals, so let's go plus 2. All right, this is going to be my equation. Now, why this is important, that's slope-intercept form. I can graph that thing. So the start of that, what's my y-intercept? The 2. So I'm going to hit the 2 here. That's the plus 2, that's your y-intercept. And then from there, I can use my slope going up 3 over 7. So up 3 over 7, right there. 1, 2, 3, 4, 5, 6, 7. And that's 1. Okay? All right, so there's an equation, a linear equation, using some basic formulas. Now, what I want is to talk about these two topics for this picture. So I want to talk about like a parallel line to this thing, or a perpendicular line to this problem, using some basic information. So like, for instance, all I really need to know is what type of line you want to come up with, parallel or perpendicular, and I just need another random point to go through. Some spot on this graph that's not on that one that I want to make sure my line goes through. Okay, so like for instance, somebody pick a random coordinate that will not be close to this line. 0, 0, okay, or 0, 7. Doesn't really matter. So let's go 0, 0. I like that now. Okay, let's make a line that's parallel. Okay, now most people know how to draw it. Like if I want to go parallel, you can do this mock sketch where you do something like this, right? That's a parallel line. They're like railroad tracks. But think back to Algebra 1 days. What do we know about parallel? They'll never touch.
Same slope.
Yeah, same slope. Those are the other things they are. They don't touch. They go the same direction. They have the same slope. That's a big one from algebra class. Geometry was obviously different definitions and stuff, but algebra, they have to have the same slope. So really, to draw this line correctly, you just use the slope going up 3 over 7. And that guarantees that you have the same exact, or you have the same type of line. Okay? Now, to come up with an equation for that, it's pretty straightforward. To come up with an equation and for a parallel line to this one right here, all I'm going to use is point slope form. Because when you have a graph, it's easy to go back to the equation if you have point slope form. So all I'm going to use is I'm going to use the slope, which is this. This is the same slope, because you guys even said that. For parallel, we have to have the same slope. So my slope will be 3 over 7. And then the coordinate that I'm going to use is going to be the 0, 0. That was the one that you guys picked. That was the dot that I know my graph is going to be going through. And again, what we're doing here is we're doing parallel. We're going to have a parallel line to the one provided. So it has to have same slope. Okay. Questions on this so far? Now again, we don't need the graph. We can do this without the graph. I like to look at it. You can see that. But same slope, coordinate, and now I can go right directly into this form. So the equation, my slope here is the m, so I have that y minus a number. My slope is 3 over 7, and then my x minus 1. Okay? Everyone understand like the setup? Now what coordinate am I going to use? 0, 0. You just plug that in here. And that'll give me my line. That'll be the equation that's parallel to the one that's provided. Now, if I need to get to any other forms, if I need to go to slope-intercept form or standard form, all I need to do is just simplify this thing. Distribute the 3/7 is 3/7 0, 0. I can literally get rid of that 0 because I don't need it. And there's so yeah, but adding subtracting is but that is your slope-intercept form, right? So that's your equation in slope-intercept form. If I want to go to standard, I just rearrange, get rid of the 7 off the bottom. But parallel is easy. Right? Parallel takes no thought. It's the same slope, you just have to have the coordinates. Now, some people, if they have the graph in front of them, you can do it by other means. Like, you know this coordinate right here, so that's what, 7, 3. And you could find old school slope. You can use 0, 0 on this coordinate to find slope by using the average formula for slope. That's that y minus y, x minus x, and then, putting the form in slope, point slope form. So, I mean, some people can do that without having to think about having the same slope and whatnot, but I think it's just easier if you just put it in point slope form. Okay, questions on parallel? Yeah, you can put it on your own. Alright, but that's parallel, not bad. It's got the same slope, it's just going through a different y coordinate. It has to, the big thing here, it has to have a different y-intercept. Because if it has the same y-intercept, then the lines are literally on top of each other. And that's called coinciding. It's not parallel. They're literally the same one. They're on top of each other. So it has to have a different y-intercept. Okay, but now, let's talk about perpendicular. Very, very different story. So we'll come up with a new equation here. Is there any questions on parallel before I move on? Yeah, I figured as much. I figured it was pretty straightforward. Let's talk about perpendicular. Alright. Alright, let's come up with a new equation, please. And you can give me pretty much any form that you like. So let's pick a form to begin with.
Standard.
Okay, I heard point slope form first. We're gonna go with that. Sorry.
That's fine.
She was quick on the draw. All right, now I want a formula. So let's come up with something with some basic numbers in it. Easy numbers. So y, well, has to be point slope. So y plus or minus a number? Plus 2 equals 4. X plus or minus?
7.
Plus 7 or minus 7? X 7. All right, there you go. All right, so there's my equations. Now, if we want to graph that, obviously we know the coordinate that I'm going through. The coordinate on this one, by the way, is 7 comma negative 2. Now, why I know that's the coordinate is because they're subtracting the 7. That's the number that's with the x. They're subtracting that. And then this number, it technically was negative 2. You have to be y minus whatever that number is. So it was y, this is a plus. It's always the opposite of that number. So it's minus 2. Okay, so there's the coordinate. What's my slope? 4. Okay, so that means I'm going to go through 7 comma negative 2. 1, 2, 3, 4, 5, 6, 7. Negative 2. All right, so there's the first dot. The slope is up 4 over 1, up 4 over 1. I can draw a line. All right, so there you go. My equation is terrible. All right, there you go. All right, so there's the equation of that line. Now, what I want is I want something perpendicular to it. So I want something perpendicular to this line. We can go through any coordinate you like. Now, this is where it's different. It's different than parallel. I want to be perpendicular. So let's think about what does that keyword perpendicular mean from algebra class? Exactly. They're making a T-intersection, right? 90 degrees. It's the different definitions of perpendicular are right angles, orthogonal, flush. Those are the words that you get from like geometry class. They have to meet at a perfect 90-degree angle. Now, I don't need to know where they meet. What I need is just where is my perpendicular line going to go through. That's all I care about. I don't care that we're going to hit that black line there at any particular spot. We can find that out later. But what I care about is what coordinate do you want this perpendicular line to go through on that grid. So you can pick any spot on this picture. It doesn't even have to be on that line. 0, 1. All right, so 0, comma 1. So this is going to be my spot, 0, 1. I'm going to make a perpendicular line to this thing going through that dot. So this is basically kind of what we're looking at, if I kind of give you a mock picture of it. It's going to be a line like that, and I need to make sure it's at a 90-degree angle. Okay, so it's probably not drawn perfect, but you get the idea, right? So we're going to try to come up with the equation that will give me that. Okay, so how perpendicular works. Obviously, we're meeting at 90-degree angles. The slope is the big part of this. The slope makes all the difference. It's what we call an opposite reciprocal. Slope is opposite, and it is a reciprocal. So what does that mean?
Flip the thing and negative.
Exactly. You flip the fraction for slope, and you make negative. That's the opposite means. Exactly. So the slope right now is 4, so we flip it, 1 over 4, and make it negative. That's my slope. Why you'd ever use perpendicular lines? It's the complete opposite of what your prediction is for the graph. So if you have a certain sales number and you know you're going up, well, what's the perfect reciprocal of it? The opposite of that sales figure is doing the opposite reciprocal, the perpendicular line to it. So maybe you're going in the complete other direction. That too. So if you're not making profits, you're making losses. So it's just making a very straight line. So again, we're going to go through the same thing. Now, we already picked the coordinate that I need to go through. So this is going to be my slope. The coordinate we picked was 0, 1. That was the coordinate we picked that we wanted to go through. I didn't need to pick any spot on the black line. If you wanted to, that's fine. We can use that coordinate, but we didn't need to. So this is mine. I'm going to use it in point slope form because that's my go-to form. So y minus a number. We know my slope. It's negative 1/4. X minus a number. Now, what were the numbers we picked? 0, 1. So 0 goes to the x. The 1 goes to the y. That's your equation right there. Perpendicular line. So in fact, if I wanted to draw it really accurate, now that I know my slope and I know where the coordinate, I could use my slope, going down 1/4, down 1. tell you that red line is nowhere close to where it needs to be. So it's just kind of guesstimating. But knowing what my slope is, I can tell you that line's terrible. But if I want to rearrange this, I can kind of show you how this works. Distributing the negative 1/4, so negative 1/4 times x, negative 1/4 times 0, another y minus 1, so I'd add the 1 across. Adding it to the 0. So this is the equation for the perpendicular line in slope-intercept form. I can draw that. So we know we're going to hit 1 on the y-axis. We already knew that. That was the spot we picked. But then that means my slope is dropping 1, running 4. So I was way up. I mean, this is where the line needs to go. Drop 1, run 4, drop 1, run 4, and this is what it looks like. It's much better for me. So it looked like it was roughly hitting, 7, negative 1, roughly. Now, if you wanted to know exactly where they hit, you would have to put them into standards form and then try to solve the system, which we did in geometry not for too long. So we can do that later. That's not our purpose today. Our purpose today is can we at least get a detailed sketch of it, and do we know how to write the formulas from in the particular forms? Okay, do you see how this is kind of fitting with what we just did? Very close. We're doing the forms of lines, and you're plugging information into them. That's all you're doing. It's just based on the same stuff you were doing in your homework. Okay, questions on parallel versus perpendicular. All right, I think I've used plenty of your time today. All right, what I want you to do is take some time today, work on your page 188. Let's try to get that wrapped up. Now tomorrow we're going to start reviewing. I may not use the whole class to review tomorrow for the test. We might talk about parallel and perpendicular stuff tomorrow again. Just make sure you kind of know it, because I am going to test you on that. That's something that you should know how to do, just because of what we've been working on this section 1 for. So I mean that could definitely be a type of homework problem I can write, or test question I should say. So we'll kind of review it tomorrow and make sure. You can move around, you can sit wherever you need to. If you have any questions, you can turn down.
I go grab my book.
I mean, it's,
Yes.
you know,
Actually, if you just want to
some
borrow
of them are kind of hard, some of them are all kind of easy. Pictures? Yeah, they're actually not that bad. Just look at your book, like you told us to, and you should be fine.
Exactly. What do you do? Read.
I remember that.
Vocab.
You can just borrow them.
This one? Yeah, that's fine. It's good. There's nothing special about that.
That's not answer. That right.
I always found that weird.
Oh yeah.
It's normal. Yeah, no answer.
How was it? What?
Derek gave me like $10. I'm beneficial to take half for myself.
still gonna be working on this. You just fixed it.
Wait, Connor, which one are you talking about? Oh.
Now, obviously, it's not going to be that long. Don't worry. So,
Right.
Hey, you dropped your cellular.
No, not really? That happened?
Yeah.
Oh.
Cappuccino. Okay.
Yeah, true. It is better than. You been there? Bailey. Bailey did? Bailey. Right?
She was trained. Report? Yeah. Are we listening to more?
sorry, when you got the phone.
Thanks. Sorry.
Reading.
Yeah, girl, we're good. Then you keep reading.
Oh, sorry.
Wait,
That was my practice test because I like my down.
You just borrow a book and as user, reason why we have our cell phone on.
This way, it's undivided.
Oh, yeah, that's right.
Because you gotta think about, like, this means there's zero rise, so there's zero comp.
What? Zero's on top. Yeah, zero's on top. Or
You're right.
when zero's on top, it's zero. And when
Zero divided by
you guys,
two.
when it's on the bottom, it's
Because you can't divide anything by 0, Teal.
You really can. Wait. So sub zero is
that kind of.
wait.
Oh,
We better write all
where? No, it's still.
No,
Probably.
Or if it rises, it has a positive slope. If it's negative, it has a negative slope. If it's
Oh, yeah, right.
there's no slope, and it looks like this.
You'll wait on that.
How you go?
no, I'm gonna wait a few years.
Or horizontal.
If it's 1 over 0,
I like the power of this.
0 over 1 is 0.
Okay, where aren't those bands?
I don't know, 1 over 0 is 1 over 0 over 1.
You were like 1,002 is 30.
You can actually do,
I was gonna say,
it's
me and
easier
Nick
to
marked
look
this
at.
at a whole site all. I just saw the grade one. And then we were trying to figure out like how much that had to cost. Yeah. Okay. So this makes more sense. So if it's vertical, then it's. I say find slope.
I like that drove
Have you actually this equation? N equals y.
I like that drove your whole conversation.
It really was. We were talking about is that velocity he has? And then I was like, you know, Ward has like 1,000 of those. He's like, yeah, I know. And then were talking about all the colors you had, how I don't think you ever won the second one.
By the way, if I were to just buy everyone from the Apple Store, I would have spent $800 on that.
Have you ever won the same one?
One over.
I don't think I've ever. Same one.
I try not to.
Negative 1 plus 1. It's negative 1 plus 1. That'd be 0 over negative 1. No slope. No slope. Or, yeah, no slope. Or, number 6 would be no slope, right? If it's 0 over negative 1. Alright. I'm a genius.
Still, you remember last time I actually worked on it? Saying, you know what? I'm fixing it.
Why'd you write down?
I don't know. Yeah, yeah, but hold on.
There's no way to.
The Nike.
What?
Yeah, the Nike band was used to Nike.
What?
I was about to buy.
The Nike band?
Not first.
Oh, really?
They have the exact.
Nick, there you go. Just get a little Apple Watch.
I'll probably go.
Do the Nike ones have like those ripples?
It's gonna work there in 3 weeks.
Why is that? I have just like I like jerseys up there.
I'll get one. I'll get black.
The black and green. Don't they only make black and green? Or is
Gray,
it black and
green,
black?
gray, black and gray, white and green.
The white one of the gray circle is green.
I'll look.
Oh, I have as soon as I turn my app, I have a job.
Yeah. Plus my sister's working on it.
What number are you guys on? What number are you guys on?
14 negative.
You guys are not. They're way I was like, I have not seen any of those.
Undefined.
Rulers?
But then, yeah, I know, but then if you do that,
But then once you get
or then it's still,
so then you always negative. So it's negative 5. There's actually I just think they're not. Come on, man. For what? It's for next year. I actually don't think it's for next year. I don't know what bad arms.
oh yeah, yeah,
Okay. Okay.
Everyone's going to be the
Oh yeah.
Why? Why? You can't say, oh yeah.
God.
Why'd you go, oh yeah?
Time to dial it up.
I lucked out 20 times today. Seth was an MVP today, and Halsey finished up my
Oh man. I tell you what. I am losing my place.
Lord, seriously?
Okay. Outside.
Oh, that's cool.
Okay. Pass the card. Stay as your class. Stay in that group. I know.
Where'd you get that?
Nice and calm.
Let me hear the Rappies sing the.
Yep.
Alright.
Can we read it?
Probably said something like,
You so wrote that up.
I had three. It was so funny.
talking big game, but I have a really strong feeling she definitely runs.
Okay. What did you say?
Hands down. I said, hands down, she runs that relationship when you talk a great game.
Alright. Hey, let's keep working. You got a couple more minutes here. You got some minutes. Take your time.
We got some minutes. It's me. You know what? I do my own thing. I don't need no bottle. I don't need no bottle.
Okay. Let me just change it.
Alright.
I went
Jack on the way.
that was the first year. That one? Yeah, it was like, this, that. Is he a high
How are you listening?
Taylor. Yes, I do. I have one.
Oh, yeah.
I helped him write it.
Oh, okay. Tell him.
It was, hold on, I gotta get out. It was like, I hope that,
Hey, just as a reminder, when is this homework due?
Tomorrow.
Tomorrow. Make sure you get it done.
oh no, I called it.
What?
He read it. He wrote it in here. He asked for my help.
I feel like that was too deep for good.
That was really cute.
No, it was probably just handwriting.
Apparently, he said
It says,
all
let
night
the roads not
long.
weather as we dance away from this poor provincial town. I've been heading to the right date. I don't miss a single shot, so will you be my guest?
Wait,
Oh,
did you not?
You got the draft?
I did. I don't remember.
And we can't get out the draft yet. We started drafting.
That was during the
It
song.
was a lot of, yeah, it was very rehearsal, yeah.
Hey, does anyone need draft pictures?
Taylor, who am I?
Yes, sir. I just grabbed it.
Okay. Anyone else need draft paper
And
for
I
this
got
assignment?
cookies out of it, so.
Speak now or hold your peace. Everyone's got draft pictures.
Yes, sir.
Well, like, it was weird because he was waiting for the background of the song, like, something like that,
You hear your
so
book
in
over
the
there?
middle of the song.
I saw somebody draft their Bugatti Bear.
Oh, this is happening
You're right.
right now.
Like,
I like saw, I was like, oh,
It's only two people doing it. Me and Kate were the ones that got
what?
about him doing it.
I guess everyone knew about it, yeah, so it's like, you know about it, yeah, you know about it, it's like,
I don't know if that makes it better.
yeah, 10 o'clock. I get 10 o'clock after night.
He has more problems than me right now.
Bye.
Hold on. Let me look it back up.
I'm so
I was
tired.
gonna say something. It's pretty cheesy. Hey, what's up? Oh. I'm not a photographer, but I can picture me and you together. That's
Ooh,
so
that was
cheesy.
good.
That's so cheesy. I'm gonna use that.
Where was it?
In the art room?
Seth, I'm gonna use that.
You never had it here?
No, I did. And then I went to study hall, and then it was in the art room.
I'm just gonna straight up 7 feet.
Why does the fire
I
alarm
straight up
go
said-
there? I did not even go in the art room.
I'm not a photographer, but I can picture
Honestly,
me
I
and
was
you together.
hoping the school was on fire.
Could
I was
be like
changing for
K-minus.
PE, and I barely had my pants on.
Could be like K-minus.
Zach and I was in Chase Filling outside without shirts on. It was too cold for that. Then we could go for that. Who knows?
Yeah. Please leave. Please leave.
My pants on, and I didn't have a shirt on. I grabbed my shoes.
Not that hard. I just gotta put these in those.
It's fixed it. Feel it. You fixed it.
I don't want it.
Touch it. It's hard. It's like plastic.
You know, this is hard. Oh.
Don't make
Oh.
it weird. Don't make
Oh.
it weird. Oh, you made it weird.
I was talking about bones. Calm down.